Hello guys, my name is Akash Das. Today I'm going to introduce of a coefficient of variations. So these are the members that helps me with doing this project. So these are the contents that helps me. So we will discuss about it. So let's begin. Introductions to coefficient of variations. The coefficient of variations is a statistical measure that describes the dispersions of a data set relative to its mean. This calculated as the ratio of the standard deviations to the mean and is often expressed as a percentage. Definitions of coefficient of variation. What is it? The coefficient of variation is a statistical measure that represents this ratio of the standard deviations to the mean of the distributions. How is it calculated? CV is calculated by dividing the standard deviations by the mean and expressing it as a percentage. This provides a standardized measure of dispersion. What does it represent? The CB provides a way to compare the relative variability of different datasets, even if they have different measurement units or mean value. Significance of coefficient of variations. The coefficient of variations is a crucial statistical measure that provides valuable insights into the dispersions variability of a dataset. It allows for a meaningful comparison of variability across different datasets, even when the mean values differ. Comparative analysis. The CB enables a direct comparison of variability between datasets, allowing the researchers to identify the relative spread of data points. Informed decisions. By understanding the CB, decisions makers can make more informed choices, particularly in the areas like risk assessment, quality control, and investment analysis. Standardizations. The CB provides a standardized measure of variability, allowing for the comparisons of datasets with different units or scales. Thank you.
Hello, my name is Kansha from PB2A. Now I'm going to speak about the topic calculating coefficient of variation. Step number one, calculate the mean of the dataset. Step number two, calculate the standard deviation of the dataset. Step number three, divide the standard deviation by the mean. To calculate the coefficient of variation, you first need to find the mean and standard deviation of the dataset. Then you divide the standard deviation by the mean to get the final coefficient of variation value. This metric gives you a sense of the dispersion of variability in the data related to the mean. Now, interpreting coefficient of variation. Understanding the numeric value. The coefficient of variation is unitless statistics that represent the ratio of the standard deviation to the mean. A higher CV indicates greater variability in the data, while a lower CV suggests more consistency. Comparing across data sets. The CV allows you to compare the relative variability of different data sets, even if they have different means and units of measurement. This make it a valuable tool for benchmarking and analysis. Number three, contextual interpretation. The interpretation of the CV depend on the specific application and industry norms. Generally, a CV below 0.20 indicates low variability. 0.20 to 0.80 is moderate. Low variability. Moderate. Contextual interpretation. The interpretation of the CV depends on the specific application and industry norms. Generally, a CV below 0.20 indicates low variability. 0.20 to 0.80 is moderate variability, and above 0.80 is high variability.
Hello everyone, I'm Sauradip Mitra. I got a talk on advantages of coefficient of variation, standardized measure, scalability, interpretability, and benchmarking. These are the advantages of coefficient of variation. Then the limitation of coefficient of variation. Context dependent, sensitive to outliers, limited in multivariate analysis, as well as challenges with small means. These are the limitation faced on coefficient of variation. Application of coefficient of variation. The coefficient of variation finds widespread application across various disciplines, including finance, economics, manufacturing, quality control, and scientific research. Coefficient of variation is particularly useful in investment portfolios analysis, where it helps investor assess the risk return trade-off of different assets. It is also employed in process improvement initiatives, where it serves as a metric to monitor and optimize product quality and consistency. Thank you. Zero point 32 increasing, it has the greatest relative variability compared to its main dataset. C has the lowest CV at 0.9, meaning it has the least variability relative to its means value. Comparing the CVs allows us to quickly assess which dataset has the most constant or secret data points. Con- Conclusion and takeaway. Key takeaway. The coefficient of variation is a powerful statistical tool that provides valuable insights into the relative variability within a dataset. It allows for meaningful comparison across data, different variable and datasets. Summary. Its conclusion, the coefficient of variation is an instant metric that helps analyze understand the different constraints of data. It has wide ranging application in fields like finance, manufacturing, and healthcare. Conclusion. By understanding the coefficient of variation, organization can make more informed decision, identify area for improvement, and efficiently compare perform across different contracts and time periods. Thank you everyone.